Phase diagram explains the different phases of matter in regard to temperature and pressure. Looking carefully at the graph, you can distinguish three main regions where a matter is more stable in the solid form, liquid form, and in the gas form. In the solid phase, it's more likely for solid to be stable at high pressure and low temperature, while the liquids, high pressure and high temperature. And for the gas, they are very stable at low pressure and high temperature. Looking carefully at the matter in the solid form, particles are vibrating so fast. They are arranged in a regular pattern, similar to a crystalline lattice. They are not fixed. They are in fixed position, but they are vibrating and moving. In the liquid form or liquid phase, particles look completely different. They are close to each other, but they are sliding. They can move more free. This means that the intermolecular forces in liquids are much weaker than in solid, while in gas, particles move at random at very high speed, colliding with one another and occupying a big space, and there are far distances between the particles. On the diagram, you can see equilibrium points. What is an equilibrium point? Equilibrium point is when particles of two phases are in equilibrium. So here at this point, you will see equilibrium between liquid and solid form. So means that the rate of melting equals the rate of freezing. Number of particles from solid changing to liquid equal the number of particles in liquid changing to solid. In another point on the graph here, you can see the equilibrium between liquid and gas. The particles, the vaporizing means from liquid to gas, equal the number of particles that are condensing, changing from gas to liquid. Another point on the graph, the solid-gas phase equilibrium. Here, there is an equilibrium between matter in the gas and solid form. The rate of depositing equals the rate of subliming. On the graph, you can see very distinct regions in the graph. Looking carefully at the point which join liquid and gas, you can distinguish here two important points on the graph. The first point, we call it critical point. This point, we call it critical point. At the critical point, here, just behind the critical point, you cannot distinguish between the matter in the liquid and the gas phase. Looking carefully at the two regions that are very close to critical point, you can see the particles at the critical point. In this region, you cannot distinguish liquid and gas, but just very close to critical point, look at the matter in the gas form and in the liquid form. In the gas form, the pressure is very high, so the particles likely to come close to each other, while in the liquid form, the particles are also at very high pressure. Come closer to the critical point, the particles are going to get mixed, so you cannot distinguish between the matter in the liquid or in the gas form. So liquid and gas phases coexist at the critical point. There is another very important point on the graph that we call it triple point. At this point, the three phases of matter coexist. If you look carefully, you can see on the right side liquid and gas and solid coexisting together. Now we'll explain the pressure. If you are at certain pressure, what will be the melting point, freezing point, condensing point of matter. Here at this point, matter is in solid form. Particles are vibrating at this distinct pressure, going horizontally. Now this is the melting point, the equilibrium point between melting and freezing. So some solid change to liquid and liquid change to solid. Going back again, you will go to here. Matter is only in the liquid phase, no equilibrium. But once it hits the line between liquid and gas, here is the vaporizing point or boiling point. There is an equilibrium here between the two phases, liquid and gas. Matter here is only in the gas phase. Particles are very far, temperature is very high, and the pressure is very low. If the pressure was very low, you can see that matter can change quickly from solid to liquid at much lower temperature. Going here to the gas phase, also the matter will change to gas quickly. At this very low pressure, matter bypass the liquid form, change directly from solid to gas. And this at the triple point, the three states of matter coexist. So just to look at the graph, you should be able in the exam to distinguish subliming, condensing point, subliming, depositing point, melting, freezing point, vaporizing, condensing point, critical point, and triple point. Thank you.